Hello everyone, it's November the 6th, Saturday. Look how we have today, single number 3. If you guys remember, yesterday I did single number by itself. So, what are the odds that we can do something similar? Wow! Oh, I didn't notice. We can go out again. Oh, I've done this before. Wow, they just recycle all the problems. Alright, give an integer array nums, in which exactly 2 elements appear only once, and all the other elements appear exactly twice. Find the 2 elements that appear once. You can return the answer in order. You must write in linear time and use only constant extra space. So it's exactly the same, except we have 2 integers will appear once. Okay. If we do exclusive OR, we're gonna have the exclusive OR of these 2 values, right? What? Okay, so, I mean, we can solve this again very easily using on log n with o1 space or on with on space. But let's try. It got to be something related to exclusive OR. Maybe we can get something else out of it. I mean, if we exclusive OR everything, we're gonna get 3. Like in the first one, will be 3 exclusive OR 5, right? That will be the result. And the question is, when we get that result, how do we get the 3 back, or get a 5 back? Good question. Only 2 would appear once. What else can you think about? Maybe we need some or and and in there as well. No, I don't think that will. Yeah, I don't think that will matter. Linear runtime. I don't know. It's probably bit manipulation. I think it's bit manipulation again. But how? How do we handle 2? How do we handle 2? All right, let's solve it first, but that will be unsatisfactory. So this will be on time and on space. So not satisfactory. But let's just do this first. Counter. Alright, it's exactly the same idea as last one. And we just do this for key value in counter. Well, we can just directly do this. We don't have to name it again. Dot items. If v equals 1, press dot append. Okay. And then we return this. Yeah. That's not what we want. We want something better. How? What's 3? 3 is 1. No, 3 is 1, 1. 5 is 1, 0, 1. Exclusive OR these two, we get 1, 1, 0, right? if we can do like another, how can we do another? No, man, I don't know. Simply have no idea. Hmm. No idea. I need a hint. I mean, we were on this yesterday, and we have no idea. Really, the topic? Yeah, it's still bit manipulation. We did this one yesterday, and that one is just exclusive or. What about today? I feel like it's still exclusive or, but there might be some trick in exclusive or. What type of trick? Like 3 exclusive or 5. Hold on. Hold on. 3 exclusive of 5. What about -3 exclusive or -5? You thought about that? 2's complement. What's 3? 2's complement. So it's going to be 1, 0, 0. So 1, 0, 1. Right? Well, actually, it's going to be 1, 1, 1, 1, 1, 1, 1, 1, 1. And then 5 is going to be 0, 1, 0. Or 1, 1, 1, 1, 1. And it'll be this. Is it possible to go, let's say, 3 exclusive of 5 is going to be, was that 7? No, 6. No. Wait, this is a 4. Yeah, it's 6. -3 exclusive of -5. I don't know. I'm just trying to figure out, is there a way to, get it, because we have 2, so we need two equations. Right, we need 2 equations. So 3 exclusive of 5, that's 6. How about -3 exclusive or -5? You gotta be kidding me. That's the same. Oh yeah, it is the same. Come on, man, it is the same. So are we saying there's no hope? This is the same for everybody? Like I said, let's put like -1. How about 1 exclusive of 5? Yeah? It is. Like the minus sign can be eliminated. So yeah, I don't think it helps. I mean, 3 exclusive of 5 is 6. So 6 exclusive of a 5 will be 3, right? But, let me think. 1, 2, 1, 3, 2, 5. So exclusive or can only work if you have 1, right? What if we say, take 1 out, take the first value out, right? And then we do exclusive on the remaining. Hold on, what are you trying to say? Well, if we exclusive or, on the remaining. Hold on, I have no data. Oh no, I have data. Yep. If we take, let's see, if I have a value and I exclusive all the remainder, but I have 2. So the only possibility is if the thing's excluded. Now that's not gonna work. Right? That's how is that gonna work? With dividing in half, how is that gonna work? Let me think. What's 3 exclusive or minus 5? Minus 8. How about 5 exclusive or minus 3? Minus 8. Let's see, which does make sense. So, what are you saying? What if they're the same? 3 exclusive of minus 3. Minus 2. 1 exclusive of minus 1. Minus 2. Huh. Let's say random value exclusive or a random value 2, 1, 3, 4, 5. Minus 2. Alright, we might be onto something. Let's say we have so we will exclusive of everybody. So now we get 3 exclusive of 5, right? And then we turn the first half into negative value, right? And the total length will definitely be an even number, right? So we can get the first half turned into negative value, the second half into positive value. So what we're gonna have, let's say minus 1, minus 2, minus 1, 3 to 5. So first half exclusive OR will give us minus 2, right? And the second one exclusive OR will give us whatever it is. And then I don't think it's gonna work, because if the same value is on the same side and then you exclusive them, they will just annihilate. Okay, and if so on if it's on either side, then the result will be minus 2. Right? Minus 2 exclusive or minus 2 will equal to minus 2. So everybody will become minus 2. But let me think about it again. So we have doubles on everybody, right? So we cut the list in half. And the first half, we turn them into negative values. And then we're going to do the first half exclusive of the second half, right? And then when we're done this happening, if the same values on either side, on either side, and those will just gone, annihilate. If they're on both sides, and their exclusive will become minus 2. So eventually, we'll turn into minus 2, minus 2, minus 2, a bunch of minus 2, exclusive OR with each other, alright? Exclusive OR with each other, and eventually, it's either going to be, like if we have even number on the left and right split, if even split, then those minus 2 will all be gone. So it will be resulting in the minus exclusive or the positive, okay? Or if if we have even, then okay, let me think again. If we have odd, like only like one pair is on both sides, then that pair can never be limited. So eventually we'll end up with -2, right? They're exclusive or -2. The -2 exclusive or, you know, the ones that we care about. Okay. So two possibilities. So we can just set up two possibilities to try. Okay, now we have two possibilities. How do we, like when we know the exclusive or, can we go back? We can exclusive of those two. So we have, in this case, in this case, right, it all depends on how many pairs do we have. Well, we have 3 pairs, right? So we have 1 pair, 2 pairs, actually 2 pairs, and in this. If we have 2 pairs, it is possible for hold on, this is crucial. This is crucial. If we have another pair, like we have like 4 and 4, and 1 4 is in the front, 1 4 is in the back, then exclusive order will be just 3 exclusive 5, minus 3 exclusive 5, right? So yeah, and if those 4, sorry, all on one side, is it possible to be all on one side? Yeah, so we cut it into half, right? It is possible that every pair is on either side, right? Every pair is on either side. Yeah, every pair is on either side. Now in this case, the ones will always the singular value will always be on either side. In this case, what we're gonna have is just the singular value. Right, let's call it A, B. So we have A exclusive of B, and we'll have either minus A, let's call it minus A exclusive of B, or minus B exclusive of A. So if that's the case, then we can exclusive or these two, right? Then we get A exclusive or minus A, which give us -2. All right, we just prove A exclusive minus A gives us -2. Well, wait, hold on. Yeah, it does give us -2. Ah, I feel like we're so close. Yeah, we only have the exclusive or, we don't have the original. What's the arithmetic for exclusive or? Exclusive or arithmetic. All about exclusive or. Yeah, I know about that. It's commutative, associative, identity, and self-inverse. Can we use some of these? I don't know. All right, in this case, we have a negative value. How do we get back to A? We have A exclusive of B. We have minus A exclusive of B. Can we get A? Right? Basically, that's the question. Can we get A? I mean, we have 3 exclusive of this is 6, and then minus 3 exclusive 5. Minus 3 exclusive 5 is minus 8. If we exclusive 6 and minus 6 and minus 8, I think this will give us what? Minus 2. Yeah, because that's A against A. That's minus 2. Okay, this is 6. This is 8. And 8 minus A would be minus 2. I don't know. This is a associative. Yeah, I know you're gonna do it A, but here's the minus A. Hold on. What if we have A exclusive of B is 6, right? And we know minus A exclusive of A and exclusive of B. We can compute that. The minus A and A give us minus 2. So we know minus 2 exclusive of B. Maybe that's the case, right? We know 6 exclusive or actually we don't know. Come on, we don't know. We just know A exclusive of B equals, we know A exclusive or A exclusive of B equals 6. And if we say we do minus A exclusive on both sides, we minus A exclusive of B. And this will be minus 2 exclusive of B equals minus A exclusive of B. That's what we have. No, minus A exclusive was 6. Now B, it's 6. So minus A exclusive of 6 equals minus 2 exclusive of B. How does that help us? I don't know. I don't know, man. What's 6 exclusive or minus 2? 6 exclusive or minus 2. That gives us minus 8. I'll go back to minus 8. We'll go back to where we start with. Okay. B equals A exclusive or 6. So minus A exclusive or A exclusive or 6 equals minus 8. Yeah, this is definitely true. Because it doesn't help us. It does not help us. What do we can get minus? Why not A exclusive minus B? Right? So that equals this. And then, let's say B equals this. minus b will equal to minus a exclusive 6. So a exclusive or minus a exclusive 6 minus 8. How does that help? I don't know. Come on, man. Oh, what was the trick? Let me think again. Maybe that's both on both sides. How do we know that they're on both sides? That's a good question. We don't know. Well, we know if the singular value are on both sides, then we exclusive of everybody, we get this, and we set one side to a minus, exclusive or we get another value. Wait, that's the same, right? Let's say 3 exclusive or minus 5, 5 or minus 3 exclusive or 5. Yeah, it's the same value. So we can pick half and then do exclusive or, right? And then in this case, if we exclusive or both, then the result is minus 2. That tells us if we do this operation, like we take half as minus, half as positive, and we exclusive or them again, and then exclusive or the results of that, which just means we exclusive or the first half. Yeah, we do the first half and turn the first half into negative, we exclusive or them, and the result, let me think again, the result, because we basically exclusive or everybody, so the result will be, oh god, the result will be, if the result is minus 2, alright? If the result is minus 2, can we say that that's an indication that the value we want to know is on the first half and the other one is on the second half? But even if we know that, how do we get the value out? We can't. All we know, like everything on the left is unique. Alright, that's the only thing we know, and everything on the right is unique. Now we can like sum and minus. Now we have like two different functions. Huh. Maybe. But can we be sure? Right? It could be what okay, let's think both are on one side, right? Let's say both are on the right side. Again, exclusive of everybody, we have the same result. What if we now want to turn first into halves, right? Well, if we have this and we exclusive of the second half, but we're still gonna get all minus 2, minus 2, minus 2, right? We're gonna get a bunch of minus 2, but the total number of minus 2's will not be the same because we're gonna have duplicates on one side, right? Duplicates on one side, so they will be 0, and the rest, oh yeah, it's still 0. It's just the result is the same. Yes, that means the result is the same, right? If we turn first half into negative, second half is positive, and then we exclusive of them, and then we exclusive or both, like no turning, and exclusive of these two values. If the value is negative, if the two values are the same, right? If two values are the same, that means they're on the same side, but we don't know which half, but we know the unknowns are on the same side. Otherwise, the unknowns are on either side. Okay. If the unknowns are on either side, then we can just sum up the first half, sum up the second half with a negative. So we have a minus b, right? We have a minus b. We get an a minus b value. I mean, in this case, they are not on the same side, but we can just turn them around, right? We can say, let's do 1, 2, 3, 1, 2, 5. Then we can minus the 2, so we have a minus b equals minus 2, and a exclusive of b equals what? Isn't that 4? No, 6. Is that 6 or 4? That's a 6. Yeah, 6, right? So we just solve this problem. And we can solve with a equals to b minus 2, and then this b minus 2 exclusive of b equals 6. Can we do that? Oh, I don't know. Exclusive OR with arithmetic. Does exclusive have distribute? What they call distributive? Does it have that? I don't know. Nah, this is. The other gates? I read it. Alright. Exclusive or distributive with plus. I don't know, just plus or minus. Propositional calculus. It's not distributive or and. Well, plus is not and. The bitwise operation distributed over addition. You cannot distribute and or over addition. Yes, no, you cannot. Yeah, okay. So that's a no-go. But we do have this this thing, right? I think I can make it work. I don't know how. So we do minus. How about we do plus? Well, the plus doesn't mean anything. Right? The plus doesn't mean anything. Plus doesn't mean anything, right? Hold on. What if we take times 2? That gives us 2, 4, 6. And minus 1, 5. What we get is 2 minus 5. No, that still doesn't mean anything. Yeah, we can find the sum. So what? We get the sum of the first half, get the sum of the second half, and then first half is 6. 6 minus 8 equals 2. Second half is 8. Yeah, that's exactly what we have in the first one. But that's about it. That's about all we can have to say. The other property is just exclusive OR. But exclusive OR, I don't see how I can use it. Because it's not distributive, right? Even if I know where they are, it's still hard. What if I leave one out? That doesn't make any... That's just like this, right? It doesn't make any sense. You leave one out. No. That doesn't make any sense. There's some property I don't know. Okay, let's try another one. It's hard if they're on the same. They're not either. What if they're on the same side? All right. What if they're on the same side? If they're on the same side, we can see that exclusive OR of them, right? Be 3 to 5, and then if we take the first half as negative from the exclusive OR everything, then it's going to be -2 exclusive OR 3 exclusive OR 5, right? Oh, that's not 0. Yeah. Because both are on one side. Yeah, both are on one side. So replace 1, replace not 2. Or replace 1 to the front. Right, and then that will give us, that will annihilate. And we'll have the remaining, 1 is on left, 1 is on right. So that's going to give us -2. So we're going to have -2 exclusive OR 3 and 5. That will be the result. So we can exclusive OR -2 on both sides. Alright, exclusive OR -2 on both sides. If it's the same, that means they're on the same side. Right, if they're on the same side, do we know which side they're on? Do we know which side they are on? This -3, -2 will be the same. Right? -3, -2, -5 give us the same value exclusive OR. If they are on the same side. What about the later? Let's say they are on the positive side. Okay. Then we basically can throw half of them away, and among them, we want to have a 1 pair that is a duplicate. Everything else is unique. So we can pick every 1 and we get a minus on the right side. So pick every 1 and the right side get a minus. But we need to find out the ones that's duplicate. How do we find one that's duplicate while everybody else is unique? You can't. How can you? I mean, if you're exclusive OR, then that becomes 0. It becomes everybody else exclusive OR. I can't even find the unique one. I don't even know, right? You don't know. So then basically, on the right side, it will be 3 plus 5 minus something twice equals the new value. But in that case, we don't have 3 minus 5. So again, I don't know. Man, I have no idea. How? How do we do this? This is frustrating. How do we do this? Oh. Alright, I'm giving up. I don't know. Let's see what I have back then. Alright, we're just peeking. Alright, let's just peek. Don't look at everything. Just take a look at peek. I cheated back then. I was cheating. So I never really understood. I probably never understood how this one is done. Oh, yeah, I have no clue. I tried. Not a single clue. I mean, I just realized if they're on the same side, we can keep cutting in half. Oh, no, you can't, because then there's no duplicates. Alright, I'm giving up. Let's see, just see the title. Bit manipulation 2-pass. 4 methods. Bit manipulation 2-pass. What does that mean, 2-pass? I mean, exclusive OR, 2-pass. I don't understand. 2-pass. Hold on. 2-pass. What if I exclusive OR everything? I got 3 exclusive ORs, 5, which give us 6. What if the next round I put 6 in there? 6 exclusive of everything. So now it becomes 6 exclusive or 3 exclusive of 5. And we know 6 exclusive of 3 equals 5. And 5, that gives us 0. Wait. No. That does give us 0. So first round, the 6, hold on, 6 exclusive of 3 exclusive of 5, that's 0. So if we put 6, they're going to give us 0. Now, that's not what we want. Nah, I still don't know. I still don't know. 2 pass. 2 pass. Nope. Still no idea. 2 pass. I thought we can pass 3 exclusive 5, which is 6, to the front. And I thought that will make a difference. But no, that doesn't make it equal to 0, which is like, yeah, it does equal to 0, but it doesn't make any change. I give up. Alright, let's see. 2 pass. We will exclude all numbers in the input array, or will be left with exclusive OR. A bit is set in the result if both bits in the same location. Now find the rightmost set bit. This will give us the rightmost bit that is different. We can now go through all numbers in the array again that have this bit set to 1. This will give us the first number. Wait, so we exclusive or the 2 values, right? And then, 3 is 1. No, 3 is 1, 1, so 0, 1, 1. 5 is 1, 0, 1. Exclusive OR give us 1, 1, 0. So we find from the right side, if we find, so we know this is going to give us 0. That means these are the same. So we find the first one, that indicates these 2 bits are not the same. Then what? And then so we have the first bit that they're not the same, okay? Then what? Rightmost set bit. This will give us the rightmost bit that is different. Rightmost different. Exactly, that's true. We can now go through all numbers input array again, exclusive of numbers that have this bit set to 1. So all the other numbers that have this bit set to 1, this will give us the first number. How? Wait, what? All numbers input array exclusive of the number that have this bit set to 1, have this bit set to 1. Exclusive or the numbers have this bit set to 1. That doesn't make any sense. We can now go through an array again, exclusive of the numbers and have this bit set to 1. I think it say A has this bit set to 1, and exclusive or everybody that has this bit set to 1. Oh, hold on, now it starts to make sense. If this bit's set to 1, we know B has this bit set to 0. And everybody else, if this bit is set to 0, then we will not consider. If this bit is set to 1 and it's another value, then it must be double. So we can exclude all of them, and this will give us A. Holy guacamole. Wow. Yep. It makes sense now. The rightmost bit trick is dope. It is dope. My God. I think I understand. Ah. Oh. Rightmost set bit. Wow. Good question. Very good question. I mean, this type of question is like you don't know, then it's hard, very hard. But once you know the trick, it's like, but still, that's a good trick. Very good trick. I don't know. Last time I had this question, I definitely did not read that. I guess I didn't read this part. I just return the two values that are, a singular, and that's it. I didn't really bother with this O1 space. But now times change, and I do bother. All right, so wow, I didn't know. Bit. I'm gonna reference this answer. Upvote it too. It was good. Okay. So I wasn't able to solve this. Was not able to solve this within the constraint, right? I check the solution. Right, check the solution here. It was brilliant. So still, we use exclusive or, but since the result is since the result of exclusive or all numbers in nums is A exclusive or B, we cannot determine A and B, but we can determine the rightmost bit that is different between A and B. That bit would be the rightmost set bit in A exclusive or B. Knowing that, we can exclusive or nums again, but picking only the values whose rightmost set bit do it again, will be the rightmost set bit. With that, knowing that the kth bit is the rightmost bit that is different between A and B, we can exclusive or nums again, but picking only the values whose kth bit is set, right? Their XOR result will give us A. I'm going to suppose A is the one that we set. And suppose A has kth bit set, whereas B has kth bit unset. We can exclude our numbers again, but picking only the values whose kth bit is set, therefore will give us A. And we can obtain B by A exclusive of B exclusive of A. So that's the trick. The trick is to identify. So the trick is to identify the difference between A and B, right? And such diff allows us to exclusive OR nums without including B, right? Including B, and the ones that are included must be either duped or A by itself. So that's that. All right, so that's O(n). The speed, the time will be the same because this is also O(n), but brilliant, right? This is brilliant. So from func tools, I import reduce, from operators import export, right? So we're going to say A exclusive of B equals equals reduce XOR nums, right? And then we need to find, we need to use the, I think it's and negative, right? So I have a value, negative will be the reverse. Yeah, so the mask equals this one, A exclusive B, and negative A exclusive B. So this is the same as binary index tree, right? So we can jump. The one we jump is the rightmost set bit. So that's the rightmost set bit. So now what we're going to do is A, right? How do we do that? A will equal to reduce or, and this we need to do. So for n in nums, and should be n and mask. It has to be this. Well, it can be like this. N if n and mask. All right. So that's A, and then in return A and A exclusive of B exclusive of A. Beautiful solution. Beautiful solution. Really, really nice. Yep, that's it. Submit it. Very nice solution. Well, it doesn't really matter the time, right? It doesn't matter the time. We're gonna record it. It's 77, but it's good. This is good. Very, very good. So this is finding the rightmost set bit. Wow, this is a good question. I recorded this. Oh, what is this method? One bit of which numbers differ. Ah, it's the same idea, but this one uses exclusive or to do it. But we can definitely do it. Two numbers differ, Find the first value, find the second value. Yeah, that's the same idea. Wow. Good. 4 lines. Oh, do we have the exact same? Reduce. Reduce. Hey, we do exactly the same. Ah, we do exactly the same. Well, I can say the last bit can also be set, right? And this is the NZ. This is the same, right? S minus 1 and or S. Or exclusive or S. Exclusive or S. Yeah. To obtain NZ is NZ equals S and minus S. Yeah, let's just make sure that we are talking about the same thing. S minus 1, if I minus 1, then those will become 1, those become 0. And if we AND these, so everybody else will be the same, except for this. This one will be 1, and I AND S. So yeah, so exclusive of S. If I exclusive of S in this position, hold on. So if I like this, right? Whatever, and then if I minus 1, this one will be 1, 1, 0, and everything will be the same. And I AND, that will be 1, 1, and that'll be 0, 0. That will be 0, and everything will be, the rest will be the same. And I exclusive or 1, 0, 0. Yeah, so it's the same. But maybe somebody has said this already. Here, that's what I post. Alright, that'll be it. That'll be it for today. I thought I was able to do one-on-one, but it took so long because it's pretty darn difficult for me. The ideal of splitting into half by checking the difference between the two values. Good technique. Exclusive or, by doing that, we are able to check the difference between two values. And from that difference, we can split the array into two parts. One is that the rightmost bit is the same as 1, and the other is the rightmost is 0. And then within each, we can do exclusive OR to obtain the single value, and then we can do another one. Beautiful, beautiful solution, beautiful solution. All right, that will be it for today. And then see you guys tomorrow. Maybe we'll do the other one. I think we have one more. All right, maybe tomorrow we can do. I think we have another one. This one. I don't think we've done this one before. Yeah. So tomorrow we'll do this. Single number 2, but I don't want to see it right now. All right, see you guys tomorrow. Adios.